Today we'll be learning about the time series visualization. Okay, so basically, time series means you have to visualize the trends of any kind of data over a longer period of time. Okay, so that's where time series visualization is used. So, in which fields the time series data is used? So basically, it's used in calculating the weather patterns, your stock price analysis, website traffics, basically every data uh, whose underlying trends can be found in a long term time period. Okay, whatever trends that evolve over time, for that we use time series analysis. Okay, as you can see on the slide, the time series is a sequence of data recorded over time. Okay, so in this lecture we'll be learning about how to load and structure the time series data and created time-based charts using Matplotlib and Pandas, and identifying trends, seasonality, and fluctuations. Okay, and last, interpret the patterns for forecasting. Okay, which so if you are new to this, just to simplify, like uh, to study any kind of data which contains any kind of changes according to the time. Okay, so for example, if you have stock prices, if you invest in some kind of stocks or mutual funds, so uh, you will always heard that it is a long term game. Okay, all the profits and losses will be uh, according to long term or short term. So that time period which defines a long term or short term, in that what kind of analysis or what kind of trends that we can see for, so that we can gain profit. Okay, so that's where time series will be used. Time series analysis will be used. Okay, so first of all, let us like how to load the data for the time series analysis. So for that we will be using Pandas, as you are using from many lectures, and in that we have to like add, make some changes to our data to make it to make it more uh, in accordance with the time series analysis. Okay, so let's go to the code and just a second. Yeah, here. So I've taken a file download. I downloaded it from Kaggle, which is basically a climate data of the climate studies of the Delhi. Okay, so as you can see, there's some field called date, mean temperature, humidity, wind speed, and mean pressure. Okay, so for that, to make it according to, so the first step for a time series analysis is that to set the date time according to the Pandas date time. Okay, well, let me write it down. And how will we achieve it? It will be like this. Df, as you can see, the code is already auto generated. Please, whenever you try that, just type to try to type the code instead of just uh, use it auto generated. Okay, data frame, not df. Basically, we are creating a new field here. Okay, let's just give it a date one so that it doesn't confuse with the date column. Okay, so here we will give date. Okay, let's see. To data frame, let me check. I think there's a error. PD to daytime. Oh, sorry, not to data frame. Let me just use this here and okay. Now it's yeah to date time. Okay, there is no attribute to date time. Let me check what's the error. PD dot to date time. Okay, I used TF. Let's see now. Okay, so let's check now what has been changed. As you can see here, now we have another column called date one. It which is according to the pandas data date time format. Okay, it may look the same, but maybe there is some uh, underlying changes in the column format that which we are not able to see here. And it's better to do it anyway because not every time you will get to see the same type of data in a file. Okay, now we have to say set this date one to index. For that, we have a code function called set index. Okay, there we will set the column date as an index of the data frame and in place two which will be permanent. Okay, if you already should know the argument in place. We have already done about it. Sorry, we have already like practiced it in the previous lectures. Okay, so df dot set index date one comma in place is equals to true. Okay, now the date one will have the index. As you can see, the date one column has been set as an index. Okay, earlier it was like this 0, 1, 2, 3, those default index. Now it has been set to this date one. Okay, so that's the first step for the time series analysis. Let's move to the next. Okay, now we have prepared the data for analysis. Okay, now what we do is just create some basic visualization at first so that uh, we can see like what kind of pattern do we see there. Okay, in example in the line in the slides they have taken sales. I am taking weather data. Okay, so let's first of all let me import Matplotlib if dot pyplot as plt. Okay, and use plt dot plot. Let's just say mean temperature. Okay, let's take mean temperature. Df dot mean temperature. Okay, and just put it the title plt dot title. Uh, mean temp of Delhi. Okay, now let's see dot plot. So as you can see, like it is some kind of a pattern here. Lots of up and downs and these. Okay, so this is it is simple basic time series analysis. Here you and on the y-axis you have the temperatures, and on the x-axis you have the dates. Okay, so That's how on 2013 1, then 2013 7. Basically, it's their year and month. Okay, so according to like the daily temperature, mean temperature of Delhi is plotted according to the time given. Okay, here that x-axis coming from the index. Okay, this date one is the x-axis. Okay, so it is a most basic time series graph. Okay, now we will see like how to interpret and understand how can we interpret meaning from these graphs. Okay, now, so first terminology that you need to learn about is a rolling average. Okay, which is basically or smoothing trend. So what it does is it helps us to reduce the noise to visualize the long-term movement. For example, let me show you, like as you can see in this graph. Okay, like there is a lots of up and down. It's a basic graph, so you may think that like the temperature is going up and down, up and down, up and down. That may not be the case because there is lots of you can say noises in the data. It's not a smooth line. Okay, it's like a wave pattern. As you can see, it's like uh, uh more like a scratching. Okay, it's not like a smooth line going up and down, up and down. It's like scratching. Okay, you have pattern going up and down, and then you also have some kind of like if someone made a scratches at every point. Okay, so what rolling average will do, it will smooth your curve, smooth his visualization curves. Okay, and it helps him to identify the trend direction. Okay, so let's try it. Okay, so df, we'll create another field called rolling is equals to df dot mean temperature dot rolling. Let's just give 7. Okay, as given an example, basically 7 is the window. Okay, over how much like are we, let's just say rolling mean is 7 means like how much uh ahead or how much to the degree we have to smooth the curve. Okay, we will see like what effect this value have by taking different values into account. Okay, rolling 7 and dot mean. Now if we plot, yeah, plt dot plot this rolling column that we just created, we will get just a second. Yeah, plt dot plot rolling, uh, plt dot show. Okay, see, now you have some smoothness in the curves. Okay, like as you can see now, you can clearly make it out like in the January mean temperature is low till we get to the like 7 July 2013 July. If you read it clearly a little bit, uh, till then we have a increase in temperature because summer arrives at that time, and then according to the autumn season or monsoon season, the temperature decreases. Similarly, it's the case in the 2014, 15, and 16. Okay, basically it's weather pattern. Like January it's winter, then till March summer arrives, and then we have on June, July, on July, August monsoon season, and then autumns and then winter. Okay, so it's basically a weather pattern. Now compare it with this graph earlier that we created. Okay, you will find it's a lot much smoother as compared to the graph above. Okay, so what the rolling did is it reduces the this basically it terms as noise. Okay, what it did was like little bit smoother the curve so that you can uh, identify the patterns more easily. Okay, now if we go let's say 10 instead of 7 we do 10. Now let's see there might be smaller more improvements in this curve. Let me like create another. Okay, let me just for comparison sake let me copy this, and this time I'm giving the 10 instead of 7. Okay, now let's see. Now let's compare. Okay, there might be a small minute uh, improvement if you are able to find out and take notice of that. Okay, so basically it used to smooth the curve so to find the underlying trends. Okay, that's what rolling does. Okay, it will be very helpful if you like uh, apply it in a real world data. Okay, it's just a daily temperature data, and it is a very small. Okay, let's just say let me find out like df dot shape. Okay, it's just for 1400 or almost 1500 samples. Okay, in the real world data you will have thousands and millions of data points. Okay, so to smooth that data curve, the rolling would be very important so that you can easily explain the end user or your supervisor or anyone you want to explain about these things, like how can we like find the underlying trends there. Okay, so for that rolling is important. Any doubts still here? Any doubts? Yeah. Okay, so let's move forward. So what are these like common patterns in the time series analysis? Okay, so first of all you need to identify the trend. Okay, trend is a long-term movement. What we did just earlier in the code. Okay, so as you can see, these mountain peaks in this visualization, these are trends. Okay, like how the temperature is changing according to the given date and month. Okay, so these are called trends. For example, if I calculate like you get if you get like get the weather report or you have the weather app in your phone, and they gives the 5 days weather forecasting ahead. Like if today is 4th, they will give you till 8th or 9th weather forecasts. Like this is the weather forecast prediction on 7th of January or 8th of January. It may be raining, it may be sunny. Okay. So how they calculated it? It calculated using these kind of trends. Okay. As you can see, these peaks for that any long-term kind of prediction. So that's the calculation whether there is a time series is used. Okay. Now seasonality. Okay, periodic repeats, daily, weekly, yearly. Okay, trend we did. Seasonality we can also like uh get from this graph. For example, these are the trends. You like from the first data point, you see the line goes up for the temperature. Okay, that means that temperature is increasing and according to a given amount of time. Okay, and then it decreases like after 6 months, okay, like weather pattern of the Delhi. And then you got the another same mountain or same peak, okay. So this is called seasonality, okay. Like over a period of time or over a certain amount of time, the pattern keeps on repeating itself, okay. Like every year you get the same type, like same uh, weather patterns in same sequence. Like in January, it's not like you will get this year you're getting winter and then the next year you will get summer in January. Okay. Uh, in January is a month of winter. Okay. Similarly, June is the month of summer. It's not like you will have some rainfall, oh, sorry, some snowfall after 2 years. So it is called seasonality. Like the the kind of patterns keep on repeating after a certain period of time. Exa- Okay. Same with cyclic behavior. Okay. Like there's some point of economic or unpredictable cycles. Like uh, for example, let's say stocks. Okay. Example, you invest in stocks, and some stocks give a cyclical behavior. Like in the first 3 months of the year, they will financial year, they will give you a huge profit. Okay. But in the uh, last quarter of the year, there there's no such demand for that company, so it may the profits may reduce. Okay. Similarly, according to the any cycle, these on keep on repeating. Okay. Similar to similar to seasonality. Okay. And irregular noises, some random variations. For example, uh, you can see for yourself, like sometimes what happens is like in the monsoon season it doesn't rain, but in like monsoon season is till August. Okay. So in September, October is starting raining, and everyone say like it's like random variation in the climate. Like it is not supposed to rain, but it does rain. Okay. And it's random. It's not like from now on the rain will happen on October. Rain will still happen in monsoon, but it's some kind of random behavior. Okay. So these are the four types of common patterns that you will find in almost every time series analysis. Okay. So any doubt up till now? Hmm. I'll ask again. Any doubt?
No, sir.
Okay. So now we will break down time series into components. Okay. What are these components? For example, as you can see on the code, we have we'll be using some kind of library called stats models, and we are using uh, stats model, and we will be breaking the time series data into seasonal decompose. Okay, like like we learned about the seasonality and the second point, periodic repeats. Okay, so we'll be breaking the time series data, and then we will see like what kind of seasonality or trends or residuals we'll see. Okay, so let's go to the code. From there, we will go to form stats models dot tsa dot seasonal code. Seasonal. Again, I'm writing it without using auto generator, so that you can also like practice it by writing without using the code generator. It may be like it may think you may think like that we can just write our own code with a tab of a button, but for your practice you need to like uh, train your hands to write the code, or train your brain to remember some kind of some at least some lines of code. Okay, seasonal decompose. Okay, so for that we will using let's just result as I'm taking the code from the PPT. Okay, seasonal decompose df mean time comma model equals to. And if you like able not able to remember, there is some kind of parameters, or if you want to study, there's also this small grid also comes with every function that you can study here, like what kind of parameters it has, just to experiment with it. Okay, let's just say model, which model we are using, additive. Okay, there are more, maybe more. Okay, so let's just see what happens. Okay, so result, we have code has been run, we have got some decompose result. I think we need to plot that. Okay, we need to plot. So result dot plot. Okay, so as you can see, uh, you got a subgrid visualization here. So what does it explain? Okay, like it gives you three things. Okay, resid, which means residual noise. Okay, seasonal, as we learned about the seasonal in the previous slide, seasonality, periodic repeats, and trend. Okay, like what kind of long-term movement the data is showing. Okay, so this is the, I guess, original. Okay, this is the topmost is the original visualization that we did at the very first. Okay, now we got trend. So basically, they, I think they applied the rolling here. Okay, so you are getting some kind of longer movement, like what kind of trend the data is following in the long term. Okay, now we have 2013, we have 2013, 2014, and 2015, and 2016, and 2017 also. So over 4 years, what kind of trend the data is following. Okay, now it's seasonal. Okay, so it's basically what is showing here is like if it's a season. I Let me check. Wait a second. So seasonal is periodic repeats, as we learned about that in the previous slide. Okay, so what it is showing here is basically mine showing like if there was no seasonal periodic repeats, the data should be zero. Okay, it would be a similar line. And now uh, it's also a very broad line here, or you can say it's just a patch. Okay, so it basically signifies like the data is showing some seasonal behavior. Okay, there's a uh, some kind of repeat pattern repeats. Okay, periodic repeats. Like you can see that there's a four repeats upon the in this long-term trends. So similarly, signal is trying to show you that. Okay. Now we have resid, which is basically residual noise. If I'm not wrong, let me check. Residuals. Okay. So residuals basically means the random uh, points, or you can say outliers, which behave differently behave differently as per the data given here. Okay. So these are the points, somewhat like you can also say the scatter plot, like it denotes like random noises or some or outliers that are present in the data. Okay, so that's how you get like this that's how the components of time series data are broken into residual, seasonal, and trend, and you will be able to like uh, when you are doing the time series analysis on any kind of data, you also need to go through these kind of uh, functions, okay, or methods. Yeah, these kinds of methods, so as to get your uh, interpretation from the data. Yeah, I can understand. Maybe right now you would be thinking like, I'm not able to understand this data at all. But with the practice, you will be able to easily understand. Today is just a introductory or basic lecture. Okay. I don't know the next schedule, but if we work on the time series, you may be able to understand these data in the all in the future lectures also. Or if you want to understand it now, you can just after the lecture try to research on time series analysis and able to learn it. Okay. Now let's move to the next. Okay. So from these visualizations, like what we can observe from these kind of visualization, like we can uh, observe the trends. Okay, from these, like from this trend part, okay, trend visualization, we can like follow like what kind of trend the data is following. Okay, since it's a weather temperature kind of data, so it may uh, follow a regular cyclic trend. Okay, like in winter it goes up, down, in summer it goes up, and then when the winter arrives again, it temperature goes down. Okay, so for example, if you work on a stock data, okay, stock, so over the time, according to the market demands or what kind of news you are getting or what kind of resources are available, you may get a trend that the stock price of company may increase, or it may decrease, or it may remain same. Okay, so for these types of visualization, we can identify trend, sorry, or seasonal spikes. Like uh, suppose something happens on the weekend, but stock market is closed. Okay, on Monday, the market may have an uh, effect on itself according to the things that happen on the weekend. Okay, so maybe there's some called a seasonal spikes. So like uh like some news arrives on weekend, like gold price increases. Okay, so it will affect on Monday, have some effect on Monday when the market opens, because on weekends the market is closed. Okay, and sudden dips like possible outages or external events, like as you can see, like there's many events happening around the world. So it may affect the market, it may increases prices of some things or may decrease the price of something due to like sudden events. Okay, so basically, and one more thing, like time series data is some kind of like live analysis. Okay, what we are doing right now is just some kind of, you can say, small data, and we are just performing some kind of visualizations and try to analyze that what kind of trends is being followed from given time period in the given time period. Okay, but in the real case scenario, the time series data is kind of live data analysis. Okay, you will get the updates in minutes, and these updates will affect the market or weather or whatever kind of field you are in. It will affect uh, even a event that happened minutes ago will affect that your trend or your time analysis. Okay, so it's sort of kind of live series analysis, you can say. In using that, you can forecast the predictions, so that, and make strategies according to that. Okay, so in this, till now what we have learned is like what time series data is. Basically, uh data which is moving along a certain pattern according to a given time. Okay, and how to visualize these trends and patterns. Okay, we did visualize this using Matplotlib. Okay, and seasonal decompose. And what are these techniques like line charts? And we first visualization we did was line chart. Okay, uses PL we use a PLT plot which created line chart and rolling averages, which is basically smoothen our curve, smoothen our data over or smoothen data or reduce the noise. Okay, like you can see like there's a lots of noise, so it may not be possible to find out the trend from this data. So we use rolling to smoothen our curves and find the data. Oh, sorry, find the trend in trend that the data is following. And decomposition. Okay, L- we decompose the data into seasonal, trend, and residuals. Okay, so we have reached to the end, and your assignment is like load any kind of time-based data. Go to Kaggle, Kaggle, and just type time series data. You can pick any kind of data like sales, weather, or stock price. What we did today in this lecture is weather data, and plot a line curve that we did in the starting, or rolling average. Okay, you can use 7 or 30 days like we did. So basically in the rolling that we were using as 7 or 10, it is basically means days. Okay, like how ahead of the time we need to uh, find out the trend in the, sorry, how far or mm, how far in time or by how far we need to smoothen the data. Okay, like you can say how far days ahead we need to smoothen the data and perform the visualized decomposition like we did in the seasonal decompose. Use the seasonal decomposing. Okay, so this is your assignment, and if you have any doubts or right, you can ask right now. Okay, so any doubts?
No, sir.
Oh, okay, then thank you.
Thank you, sir.
Thank you.